my name's John Brooke, and I work. I have a joint role at Manchester. I work in IT services, applying large-scale computing, and I also do research in the School of Computer Science. I mean, I've been fascinated for a long time by the problems in the water industry, because it's a wonder of 19th century engineering, but most of it's hidden under the ground. It's aging, we don't know the condition of it. So it seemed to me a very good thing to bring modern grid technology to this problem, because essentially you can only put sensors at certain parts of a network. You can't monitor all of the network, and you therefore use the computation to try and deduce the conditions in the rest of the network. And most of my work has been to create an architecture that can allow this to happen. Not only that, but the second part is, in order for that information to be useful, you have to get it to go out to the people that are doing the engineering. So the other part of our work is creating an interface between the grid and cloud side of it, where the heavy computation goes on, and the side where people are out in the field having to make decisions just using lightweight devices. We've done two major things. One is we've integrated machine learning technology into the water simulation models, so that the data from the sensors can actually be put into such a form that the model can compute with it. Because the simulation models were not designed to be run online. So that's one big thing we've got, and we're working currently with Thames Water and looking at the actual data and seeing how well we're predicting. And we are doing very, very well indeed, considering that we've only just started to do this. So this is very encouraging. In my talk yesterday, I showed a graph of the predicted versus the actual observed behaviour in the water network, showing that the two are very close. The second big result we've got is we've created a series of tools which allow people on mobile devices like tablets, mobile phones, to actually access the model from wherever they are. So let's imagine you're going out to make a decision. You're going to turn a valve on or off. The way you do that is very important. If you do it too quickly, you can disturb the sediment in the network, and you'll then get a flood of complaints from people. In order to do it intelligently, you have to actually understand what the condition is at the network at the time when you're making the decision. What we have is we have a central model which is being continually fed by data coming in from sensors, but we've created these lightweight tools that use Google Maps, so you can see a map of your neighbourhood and you can project onto that the results of the simulation. So you can see the pipes, you can use colour coding to look at the flows and pressures and concentrations. So it's actually a tool to enable the engineer to make the decision, not in the central control room, but where they're actually out there in the field. Well, what comes next is I've just finished a 6-month EPSRC project to actually talk to the water companies in more detail to understand their total engineering process. Because what's very important is that the tools we give them actually fit with the way they're working. You can design tools in the abstract and they can work very well, and you can give a good conference presentation or a good paper. But in order for it to actually work, you have to actually understand. So what we've done is, myself with a couple of my students who are going to be working on this, we visited Thames Water Control Room, which is quite an amazing place. It's where they have all of the people that do the engineering and the customer focused work all in one place. So if they get complaints from customers about the quality of water, they can quite easily pass that information over to the engineering group, who will look at then at the quality of the water network. And they're interested in our tools because at the moment they've got all this data, but they don't know, how to use it to make decisions. All of the extra work we've done is to present it in such a form that it answers questions.